below. Here's a circuit description of Lab 910 by Matthew Miramon. Here we have our wheel, our mass for pennies, and our DC motor. We measure the position of our motor here at 0 using encoders C1 and C2. That would be our green, yellow wires. Here we have it going to our connector. At our connector, we have this pin. These two, the yellow and blue, go into our H bridge, which we'll talk about later. We have our ground, which is the brown here, and connected here at our green, it's at 3.3, and our two encoders. If we want to increase or decrease the voltage to our DC motor, here we have our setup, our 10K potentiometer, aka our analog input, powered by 3.3 volts, ground. And here is where it tells the microcontroller how much voltage to increase or decrease, PC0. Here is the H bridge. I'll start by explaining the pin setup, followed by what's going on here between the H bridge, how this affects our motor. So the H bridge has two PWM inputs, pins 1 and 2. Pin 4 here, ground. 7 is an inputted 9 volts coming from an external supply. These are our outputs, pins 3 and 5. Pin 3 here, M1, the purple, yellow, and the white, or M1, goes directly to the motor. Pin 5, red, blue, then to the red. So the PWM input actually does two things for a motor. One, it'll determine the speed at which the angular velocity that the axle will rotate. Second, it'll determine which way it rotates, being clockwise or counterclockwise. So with the inputted signal and our inputted 9 volts, the PWM signal inputted to the H bridge is then amplified. Then with a 9 volts, it would output a voltage between -9 to 9 volts. How does it do this? Inside our H bridge, transistor switches on and off. Now for outputs, this is where the -9 or 9 volts would go. It would output either to the M1 or the M2, not to both. And here's where, depending on which one gets powered, this will determine which way the motor rotates, left or right, or excuse me, clockwise or counterclockwise.